Hello everyone, my name is Yvonne Wheaton and I'm in the Marketing Department at Software Diversified Services. Thank you for attending our webinar today on the SysperTec Virtel Web Modernization, Modern Web Interface for your legacy mainframe applications. Here's our agenda for the next 50 minutes or so. I will be introducing SDS, Software Diversified Services. Then I will be discussing the challenges posed by aging mainframe applications and more specifically, their outdated screen user interface, which needs to be modernized, and the problems with legacy mainframe application interface options. Patrick Fournier from SysperTec will introduce his software publishing organization, SysperTec, and the Virtel Web Modernization product. Following Patrick, John Bakioki from SysperTec will be demonstrating the Virtel Web Modernization product so you can see this GUI solution in action. And remember, we'll be providing a Q&A period at the end of this webinar. SDS, or Software Diversified Services, has been providing mainframe solutions to the market for over 33 years. We have over 1,000 licensed customers, including Global 500 companies. Our headquarters are located in Minneapolis, Minnesota. SDS has strived to bring software solutions to the marketplace that provide cost savings while still using elegant and state-of-the-art functionality. We are proud of our world-class support. Over the years, we've developed more solutions for the distributed environment, we've added to our mainframe portfolio, and we've partnered with key subject matter experts for excellent software solutions. Okay, let's talk about the need to keep legacy mainframe applications up to date in the ever-changing world of IT. Legacy mainframe applications are still the dominant application portfolio within large organizations. They support the mission-critical business processes. They represent multi-millions of dollars in investments made over a period of 30 years or more. They contain the organization's intellectual property and expertise. That is what makes the organization unique in the marketplace and gives it an edge over its competition. It is therefore critical to extend their relevance and the investment that they represent for years to come. But they must be constantly modernized to resist time erosion and fight back against the perceived obsolescence of their technology. Most of the time, right or wrong, management perceives mainframe cost as excessive. It has led some to question the future of their mainframe applications. Of course, we all know that migrating off the mainframe is easier said than done, and that actual savings oftentimes fail to meet expectations. In some instances, the long-term survival of mainframe applications has become questionable. Their business logic has become outdated and hasn't followed the evolution of the business needs. Their code has become fragile, and the maintenance has become risky and costly. The support staff is disappearing. Fortunately, the most visible and most annoying sign of aging is also the easiest to address. It's the lack of integration with web technologies, and more specifically, the archaic screen user interface, which prevents it from extending selected host applications in self-serve mode to business partners, clients, and consumers. And it makes it difficult to hire and retain new or temporary staff. What are the modernization alternatives for legacy mainframe applications? The alternatives are to redevelop, replace, rehost, front-end, or web-enable, in order of decreasing challenge, cost, and duration. Web enabling doesn't impact the internals of the underlying applications. Compared to any other modernization alternative, it has lower risk, requires lower test requirements, and results in lower implementation costs and shorter timeframes. Web enabling has, by far, the best value and earliest return on investment of all modernization alternatives. Web enablement can be divided into 3 areas of improvement: the creation of secure end-to-end HTTP connections from the web to the mainframe application, the replacement of outdated screen user interfaces with modern web user interfaces, or GUIs, and the interactive and bidirectional integration of mainframe applications with remote applications through web and messaging services. Web enabling won't improve outdated business logic although new functionalities and features can be added through a web user interface using AJAX technology, as we will see later on. Web enabling will not bring any improvement with fragile and unmaintainable code or disappearing support staff. Web enabling won't directly help with the containment or reduction of mainframe costs, although eliminating the 3270 presentation layer will reduce CPU consumption and improve performances. But it may change management's perception that mainframe technology is outdated, which may impact their perception that mainframe costs are excessive. It will make it possible to expose the organization's products and services in self-serve mode to business partners, clients, and consumers, which in turn will generate new revenues and reduce internal business support staffing costs to offset the mainframe cost. What tools and approaches are at your disposal to replace the outdated screen user interface of mainframe applications with a modern web user interface? Well, you could use Screen Scraper, IBM Rational Hats, a number of other vendor products that typically rely on server or client applications, or you could develop new homegrown front-end applications that typically rely on server-based .NET or Java technology. And finally, you could use Virtel Web Modernization, which is in a class by itself because it's the only 100% host-based solution that relies on a thin client browser-based architecture. Here are a few pitfalls you should be aware of when choosing a user interface modernization approach. Some of the solutions rely on running Java components on the host. The problem is that it results in voluminous code, which leads to slow response time and excessive CPU consumption. Of course, there's always the possibility of running Java on a ZAP, but unless you already have a licensed ZAP, it'll add to the cost of the solution. In any case, using a ZAP won't resolve the slow response time issue. It'll only make it worse, because switching between the general processor and the ZAP adds to the instruction path. Some of the solutions rely on middle-tier servers. Potential issues with middle-tier servers include additional cost, additional latency, potential bottlenecks, fragility, and complicated troubleshooting. Some of the solutions rely on client apps. Potential issues with client apps include high sensitivity to Java levels if the client apps are written in Java, complex and costly client support no matter what, and limited client device support. Those solutions are not mobile or BYOD friendly. Be aware that some of the solutions rely on extensive and expensive software stacks, which may result in excessive licensing costs and steep learning curves. Some of the solutions require changing the underlying application code. Regardless of the tools provided to implement this type of change, this will drastically increase risk, and by way of consequence, testing requirements and cost. It'll also delay the GUI's availability because switching from the screen user interface to the new web user interface won't be possible until all transaction programs impacted by the GUI have been modified and tested. This is a big bang approach. Some GUI solutions rely on screen scraping, which is now an obsolete technology. Some screen scrapers have already fallen off support, which creates a liability. And a screen scraping GUI is condemned to long-term screen dependency and the response time and CPU consumption penalty that comes with a 3270 presentation layer. Finally, watch out for the solution that relies on Telnet TN3270 connections. Those connections send unencrypted corporate data over the internet, and they require VPN protection, another licensing, and support cost. So what is it that you should be looking for to modernize the screen user interface of your mainframe applications? A solution that will replace outdated screens and TN3270 connections with a modern user-friendly GUI with web page presentation and ergonomics, and secure end-to-end HTTP connections. A solution that comes with a comprehensive and easy-to-use development tools. A flexible solution that can be implemented one screen at a time. With most organizations, a small percentage of the screens are heavily used and need rapid GUI replacement, while the rest of the screens may remain available but may not need rapid GUI replacement. You don't want to be forced to modernize 200 screens when you only need to modernize 50. Preferably, you also want a solution that comes with none of the pitfalls we discussed. no Java on host, no middle-tier servers or client apps, no extensive and expensive software stack, no change to the underlying application code, at least at the start, to deliver the GUI to its users as soon as possible. But you also want the possibility to gradually remove or bypass the screen user interface from the underlying programs, one program at a time, without impacting the GUI experience for its users. No screen scraping, no Telnet TN3270 connections. There is such a solution, and its name is Virtel Web Modernization. It is published by SysperTec and distributed in North America by Software Diversified Services. I'll now hand the presentation over to Patrick Fournier. Patrick is the Virtel Solution Architect at SysperTec. He will now introduce you to Virtel Web Modernization.
Thank you for this introduction, Yvonne. I think it illustrated well the challenges faced by organizations that need to modernize the user interface of their legacy host applications. Let's start with a brief overview of the Virtel Web Suite. Virtel is a flexible web enablement technology. It can be configured to serve different web enablement needs. Virtel Web Access is the thin client web browser-based 3270 terminal emulator. Virtel Web Modernization creates modern web page user interfaces for legacy 3270 applications. And Virtel Web Integration exposes mainframe assets to remote applications through web and message services and vice versa. The subject of this webinar, of course, is Virtel Web Modernization. So let's try to answer a few basic questions regarding Virtel Web Modernization, starting with what is Virtel Web Modernization and what does it do? Virtel Web Modernization makes it simple and fast to serve CICS, IMS, natural, and other transactions as modern and user-friendly web pages that deliver a genuine web experience through thin client web browsers straight off the mainframe without any middle-tier server. As you know, legacy 3270 screen interfaces have outdated ergonomics, a rigid layout, the usage of esoteric 3270 application codes, after-the-fact data entry verification, tab and function key based navigation, frozen legacy functionality and features. These outdated ergonomics result in a number of pain points. The 3270 screen interface doesn't integrate with existing corporate websites. It forces users that need to access both host and web applications to toggle between their screen and web page interfaces. The dated look undermines the true application's business value. Untrained users can drive the application. Using those complex screens to drive the application is error-prone and inefficient, especially with inexperienced users. It makes it hard to attract and retain younger staff and to hire temporary staff. It makes it impossible to extend selected host transactions in self-service mode to business partners, clients, and consumers. Virtel Web Modernization replaces outdated green screen ergonomics with modern web user interface ergonomics. The web page layout is flexible. For example, several screens can be replaced with a single web page. Data entry is assisted with widgets, checkboxes, drop-down lists, graphical calendar, and so on. Esoteric application codes are hidden from users who do not need to know or use them to drive the application. Data entry verification is immediate. The navigation is that of a real web page. It relies on mouse, point and click, and buttons. New application features and functionality can be added through the web user interface without changing the legacy application, typically by using AJAX, which is asynchronous JavaScript and XML technology. Virtel Web Modernization provides the benefits of a modern web user interface without having to change the legacy application. The new interface integrates seamlessly with existing corporate websites. The legacy host application looks and behaves like a modern web application. Users cannot guess that they are actually accessing a mainframe application. They think that they are accessing an actual web application. Widget-assisted data entry makes it easier and more efficient for users to drive the application regardless of their experience with the application. Instant data entry verification reduces the data entry error rate. No training is required to drive the underlying application. It makes it easy to attract and retain younger staff and to hire temporary staff. It also makes it possible to extend selected transactions in self-service mode to business partners, clients, and consumers. So how does Virtel Web Modernization work? Virtel Web Modernization relies on a thin client, web browser-based architecture, which means that Virtel serves modern HTML, JavaScript, GUI pages to client web browsers straight off the mainframe and without middle-tier servers. 3270 application screens, such as those of CICS, IMS, and other 3270 applications, are served by Virtel as HTML, JavaScript GUI pages with modern GUI ergonomics. Those pages can be rendered by any web browser running on any web-enabled device. Consequently, Virtel works instantly with any web client, any version of Windows, any Apple product, any tablet or mobile device. Virtel's unique architecture also makes for simple and rapid deployment. There is nothing to install on clients or on middle-tier servers. Users simply point their web browsers to an installation-defined URL to reach the logon menu. And finally, Virtel's unique architecture makes for simple support. There is nothing to support outside the mainframe, no client app, no middle-tier server, and no Java assets. The support is 100% host-based. Unlike other GUI and web portal solutions, Virtel Web Modernization doesn't use middle-tier server or Java components. It eliminates the issue typically associated with middle-tier servers, namely additional hardware, software, and support cost, additional latency which can lead to slow response times, a potential for bottlenecks, load balancing, and scalability issues, additional complexity and fragility, additional components to troubleshoot when something goes wrong. It eliminates the issue typically associated with Java components, namely additional complexity and fragility caused by the sensitivity to Java levels, and voluminous Java code layers which can lead to slow response times. Now let's review step by step the Virtel Web Modernization processing flow. 3270 applications such as CICS, IMS, and Natural have a screen-based user interface. The screens are served to users by VTM through telnet connections. Virtel, which runs as a starter task on the mainframe, behaves like a regular VTM terminal. But behind the VTM relay are a protocol converter between host and web connection technologies and an IP server which manages the HTTP connection with web users. To generate a web page, Virtel uses a script or scenario to associate the 3270 screens to pre-developed HTML JavaScript templates and inserts the 3270 data coming off VTM into those templates to create a modern GUI page. That page can be rendered by any browser running on any device. Now, with a solution running on the mainframe, the question that immediately comes to mind is how much CPU will it consume, and will that consumption impact the mainframe costs? The answer is that Virtel consumes just about the same CPU as the 3270 middleware it replaces. But how come? It's because the smart of the web page are in the JavaScript HTML code which runs in the client browser, not on the mainframe. As discussed earlier, Virtel CPU usage is limited to inserting the 3270 data coming off VTEM into a pre-developed web page template and sending the finalized web page to the user via an HTTP server. When it comes to performance, Virtel typically outperforms the 3270 terminal emulators, web portals, and GUI solution it replaces because it uses a uniquely short end-to-end instruction path. This is achieved by running only assembler and C++ code on the host, no Java, and using no middle-tier server or client app. Note that multiple instances of Virtel can coexist on the same system, and that Virtel doesn't have to run in the same partition as the 3270 application it serves. Instead, Virtel can run across LPAR on a single system or across systems in a sysplex configuration. The bottom line is that Virtel is as fast and scalable as the mainframe it runs on. So is Virtel Web Modernization a screen scraper? No, Virtel Web Modernization is not a screen scraper. Unlike a screen scraper, Virtel Web Modernization doesn't interface with the host application through actual 3270 screens. Instead, it interfaces either through the 3270 data flows coming off VTEM or through COM areas or channel and containers if and when the screen interface is eliminated. Virtel Web Modernization runs on the host and doesn't use any middle-tier server or client app as Screen Scraper would. It relies on end-to-end HTTP connections, whereas Screen Scrapers rely on Telnet or TN3270 connections. And it is not as sensitive to underlying application change as Screen Scrapers are. Now, how secure is a Virtel Web Modernization? A Virtel Web Modernization relies on end-to-end client-to-host HTTP connections. Those asynchronous disconnected connections are closed between exchanges, which is most of the time. Of course, a disconnected connection cannot be attacked. Those connections can also be encrypted, in which case encryption is provided through ATTLS. Exchanges between host and client are uniquely authenticated using a proprietary system of dynamically generated exchange-level tokens. This prevents man-in-the-middle attacks. Virtel also controls the IP address and message lengths with each return from the client to the host. This prevents outsiders from infiltrating the dialog or from appending malware to an incoming message. Of course, Virtel connections are compatible with proxy, SSO, VPN, actually any IP security, including biometrics, multi-criteria authentication, and so on. Virtel supports terminal and printer control. And the fact is, with all those integrated IP security features, many Virtel customers have simply dropped their VPN. Virtel Web Modernization provides integrated logon authentication. Because Virtel runs on the host, behind the host firewall, its code is protected from internet hackers. And Virtel breaks and redirects the connection from client to host, in other words, from HTTP to SNA, which makes it quite challenging for internet hackers to reach the host application. Finally, Virtel clears the browser's cache at the end of a session. With dataless client, of course, there is no host data that can ever be exposed in case a client is lost or stolen, which is a real issue with mobile devices. Now on to implementation. How do you develop a new GUI with Virtel Web Modernization? Here is a diagram that shows the data flow from the host application to the client. At the center is a Virtel product with a protocol converter between host and web technologies at its core, and a vTime relay and HTTP server to interface respectively with the host application and web client. Note on top the Virtel scenarios, which are scripts that control the internal logic of the exchange between host applications and web clients. Virtel scenarios are developed using an IDE called Virtel Studio. Note on bottom the Virtel templates, which are HTML JavaScript files that control the web page presentation and ergonomics, and the insertion of host application data into those web pages. Virtel templates are developed using an IDE called Virtel Screen Redesigner. Now, let's review the Virtel scenario, which are used to control the internal logic of the exchange between host applications and web client. They are coded in a proprietary Virtel scripting language. They are used to identify the screens and match them to web page templates. This could be a one-to-one or an n-to-one match. Scenarios are also used to control the navigation from screen to screen. The useless screens can be skipped or walked through. Data can be collected from several screens and consolidated to develop a web page. Scenarios can also be used to start ad hoc programs that run on the host. This is typically done to add new application features through the new web user interface. Now, let's review the Virtel templates, which are used to control the web page presentation and ergonomics. Virtel templates are made of standard HTML JavaScript code plus Virtel tags. The Virtel tags are used to control the insertion of 3270 data into the templates at execution time. With those Virtel templates, the 3270 screen fields are replaced with HTML JavaScript widgets. For example, checkboxes, drop-down lists, and graphical calendars. Widgets are pre-existing components that can be reused from HTML JavaScript libraries such as jQuery and Google and many others. Manually developed HTML JavaScript code can be inserted into a Virtel template, typically to add new Ajax-based application features such as auto-suggest and autocomplete without changing the underlying host application. With a web user interface served by Virtel Web Modernization, application users make plain English selections, but Virtel returns the expected code value to the unchanged host application. So, who does what to develop a GUI using Virtel Web Modernization? It is in fact a cooperative effort that involves both mainframe and web application developers. Mainframe application developers bring their understanding of the 3270 application and authorized field values. They do not need any HTML JavaScript coding expertise. They use the Virtel IDEs, Virtel Studio and Virtel Screen Redesigner to develop a first version of Virtel templates and scenarios. They can also develop the specification of new GUI-based application features if any are needed. Web application developers bring their HTML JavaScript coding expertise, but they do not need to understand the 3270 application. They provide the cascading style sheet and upload it to Virtel Screen Redesigner. They finalize the Virtel templates with custom HTML JavaScript code insertion, and they implement the new GUI-based application features using Ajax technology when needed. So the question is, can you ever get rid of the 3270 screens once a GUI has been developed? And the answer is yes. With Virtel Web Modernization, you can eliminate the 3270 screens one program at a time after the GUI has already been developed and deployed and without impacting the users. This is because Virtel supports different ways to interface internally with the 3270 applications. Initially, Virtel interfaces with the 3270 applications through their existing screens so that the application code remains unchanged. But eventually, after the GUI has been deployed in production, possibly years later, the interface between Virtel and the underlying application can be changed to COM areas or to CICS channels and containers. Of course, this type of change requires changing the application code, but it can be done progressively, one program at a time, without impacting the web user interface. We will next discuss an example of a screen to COM area evolution with one of our customers, a global bank. Let's review a couple of customer stories now. Here is a global bank that approached SysperTec over 10 years ago. They needed to develop a GUI for a CICS application, but at the same time, the application was undergoing a vSAM to DB2 migration. So their requirement included integrating the new GUI seamlessly within their existing website and leaving the application code unchanged to avoid interfering with the DB2 migration changes. In 2005, the customer developed a modern web user interface that only uses very simple JavaScript widgets such as drop-down lists, graphical calendars, and checkboxes. No AJAX technology and no new application features and using the screens, something very straightforward. Then in 2008, the customer added new application features using AJAX technology. And finally, in 2011, the customer eliminated progressively throughout the year all screens, replacing them progressively with COM area. The internals of the application and the GUI remain unchanged, so no change to the user experience. Only the interface between the application programs and Virtel changed. Now, on to a more recent customer story. A few years back, the Department of Revenue of a country in Europe approached SysperTec to replace a failed HAT implementation. What happened is that they found the software licensing cost to be excessive, the development to be overly complex, lengthy, and costly due to the fact that they needed to change the programs, and more importantly, the response times were simply unacceptable. With Virtel Web Modernization, they were able to lower the software licensing cost, simplify and accelerate the development because there were no program changes required, and their response time were much better. In addition, they were able to leverage Virtel's integrated PDF generation facility, which allowed them to eliminate over 2,000 unsupported printers. That alone paid for the GUI implementation cost. Well, I hope that you have now a better understanding of what Virtel Web Modernization can do for you. And at this time, I will hand over the presentation to my colleague, John Bakioki, who will demonstrate Virtel Web Modernization with a small sample application.
Thank you, Patrick. I'd like to give you a brief demonstration of an application that was created using Virtel Web Modernization so that you can see how it works and what it looks like. To start, I'd like to show you an application in its original 3270 screen-based format as presented using Virtel Web Access. The application is a simple two-screen application that could be used by travel agents to book trips and cruises for clients. Navigation is controlled by using PF keys, the PF8 for the next screen and then PF7 to get back to this screen. Data must be entered as the CICS application expects it to be entered. Users must therefore become familiar with valid values and formats for CICS application codes. Dates must be entered in DDMMYY format, because this is the format expected by the CICS application. In addition, data entry is not intuitive because this is the way the CICS application was designed. For example, users must enter the return trip data in full, even though it could be assumed from the outward trip data, as travelers typically return from the location they traveled to the location they traveled from. I will now change the PDT code and press Enter on the keyboard to validate the screen entries. Note that entering bad data is not detected at the time of the data entry. It is only detected after all data has been entered and the Enter key is pressed. To correct a bad entry, I must return to the PDT field and enter a valid code. Now that the data is correct, when I press Enter, a message will appear in the screen stating that the data is valid. I will now navigate to the second data entry screen by pressing the PF8 key, where more data would then have to be entered. This would include entering the name and address of the traveler, even if the traveler was already known to the travel agent. Now, let's show the same application as modernized using Virtel Web Modernization. This demo illustrates the look, feel, and additional features and functionality that one can get by custom developing new Virtel presentation templates. As you will see, the presentation and functionality are greatly improved. However, none of the CICS application code from the original application has been modified to implement the new web presentation and features, and both the original 3270-based application and the modern presentation remains available at all times. The 3270 users will see the legacy 3270 screens, while web users will see the new web pages. Now let's look at the improvements that are provided by Virtel Web Modernization. The PF key navigation of the 3270 interface has been replaced by tab navigation. The tabs Travel Reservation and Client Information correspond to the two CICS 3270-based application screens. The record status field is specified via a static drop-down list. Plain English literals are shown to the user, but CICS application code values are returned to the CICS application, which is unaware of the drop-down list. The package type is specified by a dynamic drop-down list, which is generated from a file accessed either on the mainframe or within a client-side network. Upon selection of the package type, a context-sensitive drop-down list that shows the travel packages available for sale that day is created, and the pricing and minimum deposit information for a default number of 4 travelers is shown. Next, I will select the traveler's count, which leads to automated recalculation of the price to adjust it to the traveler's count. Cancellation insurance has become a selection box where if I check it, it means that cancellation insurance is requested. Clicking on the Trip Planner plus sign opens a new area within the web page which is pre-filled with departing and returning country and airport information based on the selected travel package and generated from information external to the mainframe application. Clicking on either date icon triggers a JavaScript widget that displays a graphical calendar. The selected date value is returned to the CICS application in the selected day-day, month-month, year-year format. And clicking on either time field triggers a JavaScript code that displays a drop-down list with hours. Now I will click on the Enter button to validate the entry. the message journey data entry validated is displayed. Now I will click on the Client Information tab to move on to the second CICS screen. Clicking on the tab is translated to a PF8 key within the mainframe application, and the CICS application responds by sending the next CICS screen, which the Virtel HTML template displays as a new page. The client name entry has been upgraded with an AJAX suggest function so that a list of past or existing client names is suggested while the name is being typed. The user can select one of the suggested names at any time or type the entire name. I will select Arnu, and note that if the name of an existing customer is selected, the address, zip code, and city fields are automatically completed. The client's email address must be entered manually if the user wants to later on send an automatically generated invoice to the client as an email attachment. I will now enter my email address in that field and then click on the Enter button to validate the second screen data entry. And the message validation OK, case validated for this customer, is displayed. If I click on the client history plus sign, I will trigger yet another added feature, which is a custom developed transaction that is executed to retrieve and send back the client travel history, which is displayed as a table using an HTML widget. The table rows can be sorted based on any given column data by clicking on the column header. Clicking a second time on the same column header changes the order in which the rows are organized. Finally, the new presentation allows the generation and emailing of an invoice in various formats, either PDF, comma-separated value field for a spreadsheet, or XML. It uses JavaScript code and a PDF generation program supplied with a Virtel product to generate an invoice from the trip data entered to this point. To activate it, I'll select the invoice format, which will be PDF. I'll click the Send Email button if I want to generate a document emailed to the email address entered in the client contact information, and then click the Generate button. This generates, displays, and optionally emails an invoice in the selected format, which can then be saved or printed. This concludes the demo portion of the Virtel Web Modernization presentation. I will now turn control over to Yvonne Wheaton so that we can start the question and answer portion of the presentation.